Okay, so in this video, we're going to look at how to do a hypothesis test, testing the difference in two proportions using the graphing calculator, the TI graphing calculator. I'm going to use this example again. I've used it a couple times before. 83 parents of students in Wethersfield were surveyed regarding full-day remote instruction instead of a traditional snow day. Of the 83 parents who were surveyed, 52 were parents who had elementary school-age children only, and the other 31 parents had middle and high school-age children only. So of the 52 parents of elementary school-age children, 18 responded in favor of a full-day remote, and the 31 parents, 10 responded in favor of full-day remote instruction. And what we're wondering here, middle paragraphs, is test at a 1% significance level whether it can be concluded that there is a difference in the proportion of parents of elementary school-age students who support the proposal compared to parents of secondary school-age students. Theory being, parents of elementary school-age children and the parents of high school children may feel differently about whether we have a traditional snow day or to do remote instruction on that snow day. So if I want to do a hypothesis test to determine is there a difference in those proportions, my null hypothesis will be, of course, that P1 minus P2 is equal to 0, that there is no difference. So in the graphing calculator, to test the difference of the proportions, we're going to go to Stat, Test, and we're doing number 6, a two-proportion z-test. So we're going to select number 6, the two-proportion z-test, and I'm going to let group 1 be the first group, the parents of elementary school-age children. Okay, there were 52 of them. Okay, notice of the 52 parents of elementary school-age children, 18 responded in favor of full-day remote. X is the number of the 52 who responded in favor. Last sentence, first paragraph, of the 31 parents of middle and high school age children, so there were 31 of those parents surveyed, and 10 of them responded in favor of full remote day instruction. And we're going to do a test to see if there's a difference. Okay, if all we're doing is testing to see if there's a difference, we're going to say that P1 is not equal to P2. If you're testing to see that if P1 is greater than P2, you would select greater than. If you want to test to see if it's less than, you would select less than. We're looking to see if P1 and P2 are different, so we select not equal to. Calculate. Calculator gives us our values. Notice that Z is equal to 0.22. Okay, our P value is 0.826, which is huge, right? We're going to compare P 0.83, 0.826 to my alpha value 0.01. Clearly, P is greater than alpha. You notice that the P hat 1 and P hat 2, 0.346, 0.323, we're testing to see if there's a difference between 34.6 and 32.3%. And we're finding that there is not a statistically significant difference because P is greater than alpha. P hat here, the 0.337, recall what that is that there were 83 parents surveyed, some parents of high school, some parents of middle school and elementary school age children. But there were a total of the 83, a total of 28, 18 elementary parents and 10 middle and high school parents. 28 of the 83 responded in favor, and that's this P hat 0.3773. Okay, so since P 0.826 is greater than alpha 0.01, we cannot reject the claim that there is a difference. Okay, so there does not appear, we cannot claim that there is a difference. Is there a difference? There does not seem to be a difference in how they feel. If I want the 99% confidence interval, stat, test, and I'm going to go down to the two proportion Z interval. Okay, that's option B here, two proportion Z interval. And when I select that, notice again, it has already pulled in my data. X1 is 18 and 1 is 52. 18 of the 52 parents of elementary school age children, 10 of the 31 parents of middle and high school age children responded in favor of full remote day instruction instead of a traditional snow day. Find the 99% confidence interval. So we've got the 99% confidence interval, and we're simply going to cursor down and hit calculate. And we see our confidence interval from negative 20.252 to 0.299. So in other words, somewhere between 25.2% fewer to 29.9% more of parents of elementary school age children favored the new proposal as opposed to middle and high school parents. Okay. So there's, again, a brief look at the graphing calculator and how to do a hypothesis test of the difference of two proportions, including the confidence interval.